Okay, good. All right, good morning. I think it's not our opinion. That's how the Hey, whoa, Rex, now it's very loud. Just continue to know. Same morning. Okay, good. All right, so we are 5 days delayed, behind time, but uh, and then we'll just start off quickly. People will come in, and I know when we have the speaker like Chong Lee Siong, always warm. The seats are always takes. I think everybody loves to hear him. And I probably gonna have to do a long introduction with that again later on. So we'll quickly jump and I'll pass over to our sponsor and for her to present product. So please welcome Ms. Lee.
A very good morning to all of you. My name is Chong Lee, the Assistant Business Development Manager of Wisely Factory. Okay. First of all, I would like to extend my warmest thanks to every one of you for being here with us today. Okay. This is our first time with for 10 modern chapter, and we are very happy to be here to show you on our product and also our okay. Wisely Industry is a local manufacturer for aluminum composite. We have been in the market for more than 10 years. We started small, working on bigger projects, and now we actually see our presence in quite a number of projects. We supply our project to high-rise project, residential, commercial, and then factory project, government building, hospital, toll plaza, and also MRT station. Okay, so before I start with my product introduction and also our company background, please allow me to share you some of our completed projects. So from the product showcase here, you can actually see this project apply our ACP, aluminum composite. Okay. The first project that I'm going to share with you is TFAMD Microelectronics and Battery Tower. This is our project in Cladding. This building actually comes in a sleek and also modern design, where they actually apply our ACP for the external wall cladding. So you can see the silver color wall is actually cladded with ACP, alright? And we're using our metallic finish ACP, okay? And then for the second project, Infineon Marker, this project is actually by Lee Siong. Yeah. So the building of Infineon actually they get ACP for the white color wall on the left side there. So how do I
Lisa?
Okay, yeah, sorry. Okay, so the left side here is actually covered with ACP. So you can see the white exterior here. Actually, it makes the building looks clean and also elegant. And Fabric Tower, this is the mixed development project in Dallas, Malaysia. There are 2 towers for this project. One tower is commercial and the other one is residential. So for the commercial tower here, they actually apply the ACP on the what we call it, vertical column from down to top. And also they apply the ACP for the link bridge here. So for this project, we are using silver color, which is in the Cladding series as well. And then the third project, the next project is the Mano KL. For the Mano KL, this is actually a high-end condominium, okay? And then where they apply our ACP is on the podium here, where they do a curve clean on the podium. Okay, so the panel here is actually installed segmented in a smaller piece in order to form the curve shape. Okay. And this project is using our Cladding series of solar. Then the next we have M resort and or hotel at KL. For this project, we are using our special series, which is stone grain and also wood grain. Okay. So for this one, we are applying on the excellent cladding and also the coating here. Next, we have JPR HQ at Jalan Salamudi KL. For this project, they also apply on the excellent cladding, which is the silver color cladding. And the next one will be sales gallery project. So for IJN, sales gallery, you can see they actually apply ACP for 3 areas. The first one is a mover seal, and then the second one is a ceiling, and also the wall hanging here. Okay, so for this project, we actually using our special. We actually do a special color matching for that. So for us, we always can do color matching. Let's say the color that you want is not what we have in the standard color. Okay. And then for Pinnacle Sales Gallery at gallery, this sales gallery actually come in a very central 3D design, where the cladding is actually cladded in a 3D form. Okay. And the panel is actually resolved piece by piece. And the size of the individual panel is actually kind of different sizes. Okay. And then interior axis, this is a newly built hotel near the okay. For this project, the main building envelope is actually glass, but they also apply ACP for the horizontal area here. Okay, and this project they are using our brush finish ACP. Okay, so for us, we don't only supply the standard solid and metallic colors, but we also supply the wood look-alike or stone look-alike ACP, as well as hairline finish. Okay, but one thing about hairline is it will be easy to be corrected if you don't do maintenance. So regular maintenance is very important for this kind of finishing. Okay. And then central streets at KL Center. For this project, they apply our ACP as a decorative for the podium level here. So you can see the vertical panel here is our ACP. Okay. And then SUKE Toll Plaza. This one they are applying for the what we call it decorative purpose also for the top panel here. Then they have the silver color panel and also they tag with their office. The XN project is Virginia. For this project, they use different color with the mixing of a solid and metallic series. Okay, so basically you can see the whole building facade they tag with ACP. Okay. Then next we have Pusat Jantung Hospital at Serang KL. This project mainly is for the drop-off canopy and also the roof edge. Okay. And then MPIP at Johor is for the roof and also the external cladding. Right. And we also supply to MRT project. This project actually completed early last year. So for us, we supply for all their 8 underground stations. Okay? Mainly is for the application of internal wall. So every station they actually have their own color scheme. So some they use solid color, some they use metallic, and some they mix and match with high gloss and also solid color. You can see the color here. The same color but come in different finishing, high gloss versus solid. Okay. And for this project, actually, we supply them close to 20 colors, and most of the colors is expected color when we do color matching for them. Okay. Now, I'll give you a brief on our company background and also our product. Okay. So, bicycle industry is actually established in the year of 2008. We actually a group and we're actually a company under bicycle group. So for information, bicycle group, we also have a sister company where they are also a manufacturer, but they are producing more on aluminum foam products. Their products like aluminum bifold, side door, and also swing door, as well as aluminum kitchen cabinet. Okay, so it's two different companies but under the same umbrella. Okay, and then our HQ is located in Muang Johor. Our annual turnover is actually around 70 billion, and currently our focus is Malaysia local project. But we do also supply to overseas project based on our project basis. We supply mainly to the Southeast Asian countries. Okay. Product wise, our product is actually strictly confined to local authority requirement and also mobile. Okay, so for panel is actually tested with MS 257017 and classified as a we are certified with this PPS certificate identity. Okay, and then for mobile requirement, our product is tested with BS 475 and certified as a classroom material. And of course, we are also tested as BS 8414 material, meaning we are tested in a full year system test and we got the FORMA certificate for 8414. Okay, and also EM 3501 for the besides that, our product can also contribute in the point. You have every kind of product to bring agents Malaysia. Yes, I thought that for many projects, it will be a must for every project to certify as a green.
Sending a notification.
Yeah, so we actually contribute in that for our product. Okay, for certification, as what you can see from my earlier slide, it can be used for exterior, interior, or as a decorative. Okay. So this is our factory in Muang Johor. Our actual location is actually in factory in Northern Malaysia factory. So currently we have two production line in the factory, and the two production line here can produce up to 240% scrap panels in a month. So in a month time, we actually supply up to 20 or more than 20 projects. That's not an issue for us. Okay.
But this is just me.
This is our laminating line in our factory. So this is where we do the sandwiching process. Okay. And we always welcome architect to visit our factory so that we know how to actually produce. Okay. So in order for us to deliver the highest quality of product to our customer, we have a very comprehensive so start from the raw material until finished product inspection. So the main QC checking that we do for the raw material is mainly to make sure that the coating is in good part. So we do different tests for coating performance. Okay. So before we send it to the production, we will do coating performance test and also some other material testing. And after that, after the production of the finished product, the two main tests that we do is pre-dry test and also boiling water resistance. So basically, these two tests is to make sure there is no delamination. Okay. And this is what we have and what we produce in our factory. Basically, all our ACP are 3 layers assembly, but come in different set for different application. Okay. So we have ACP for external application. We have ACP for interior use, awning and roofing, and also siding and the board. But today our focus will be the ACP for external application. Okay. So for external application, ACP need will meet the requirement of MS 257-2017. I believe you're familiar and you know about them. So I will just quickly go through about this. The key highlight is the ACP used for external cladding. The core material must be plain resistant, meaning the core material have to consist of minimum 70% of non-combustible mineral. Okay, and then of course the panel have to be tested with BS4 sensitive practice and classified as a partial material. Okay, and then for coating durability, the panel coating, the surface coating of the panel must be a fluorocarbon coating with 70% of PVDF. Okay, this is to ensure that the coating can transform, right? And then this is our certification for ACP for accelerated. So the panel thickness is quite standard, which is 4 mm in total. And our surface coating for information, we use PPG coating, PPG Urana, where this coating is actually consisting of 70% PPM the same, right? And then we have our standard size for. So when we supply a panel to the contractor, the subcontractor, it's actually in a flat sheet. So the fabrication will be done by the fabricator, right? So the standard size that we have is 1250 for the width. Then the length we can go up to 6 meters. Okay. So in terms of ISCP compliance, actually the usage of ISCP material in design is actually very important. Following the London fire case in Braga Tower, actually now they are very strict on what we call it material against for accident cladding, especially on high-rise building. Okay. So I believe you all know about this fire case. So this case actually cost to 72 because of the use of highly combustibility cladding material. Okay. So our F1ACP, particularly F1ACP, is actually designed to limit the spread of flame to slow down the fire growth. Okay. So the core material that we have in our F1 panel ACP is actually containing of 70% of non-halogen magnesium hydroxide. So for the material itself, for this magnesium hydroxide itself, it plays a very important role where it will actually help to absorb heat from the material surface when there's a fire, and eventually it will help to cool down the building and also reduce smoke suppression effect. So this can actually give more time in order to evacuate the building in case of fire. Okay. And this is what our product has been tested in terms of fire performance test. Okay. So basically our product is tested with both material test and also system test. Okay. So this test actually evaluate the reaction of a material against fire, including flame spread, smoke development, and also burning risk. Okay. And of course the overall fire performance also. Okay. So a quick explanation on the fire test that we have done on both. So against force sensitive particle and class 7 is a must for the material or the product to be classified as a class O material. And to achieve a class O, the result for class 6 test, which is the fire propagation index, fire propagation test, the index for fire propagation index must not more than 12, and then the sub-index must not more than 6. Okay, so you can see our result here, we actually need the requirement. And then for 7 test, in order to classify as a class 1 material, class 7 tests have to achieve class 1. Okay, and how to achieve class 1? The plane spread distance for class 7 test must not more than 165 mm. Okay, so you can see this is our test result. So basically, we achieve a class 1 for class 7 test. And with the 2 test result here, our material is classified as 4 material. Okay. And then Next, this is ASTM E84. So I'll go to the earlier slide first. EN 13501. This is EN standard. And this EN 13501 is actually a fire classification of a construction product and also building element using the data of reaction to fire test. So for this fire classification, there are two main tests that we need to do, which is product inactivity test and also single dwelling meter test. Okay, so with the two tests we have here, our panel is actually classified as a class B material under EN standard. And the next reading, which is the smoke production reading, is 1, meaning there's a very little smoke during the fire test. And the D reading is 0, meaning there's no droplets of liquid during the test. Okay, so from the fire classification here, we can tell that our panel actually have a very little contribution to a fire. Okay. And ASTM E84, this is also a fire test, but mainly for material emission. Okay. So the test result for this ASTM E84 we classify under class A, B, or C. Being class A is the most fire resistant. And you can see on the test result here, we achieve the class A for ASTM E84. But so far for local bomba requirements, EN 13501 and ASTM E84 is not a must. But then for class 4 and EN 8414 is a must for local bomba requirement, right? So 8414, as I mentioned earlier, this is a full-scale system test where every component used in the cladding system will have to be tested together as an assembly test in order to be compliant. Okay. So the test duration for 8414, it will take longer time compared to material test. So the total test duration is 16 minutes. And how they do the test, they will begin the test with the ignition of the cladding system at the bottom of the segment. Okay, and then the testing criteria, there are total 5 testing criteria in order to classify the test. Okay, so the testing criteria for the first 15 minutes, they will observe on the plane spread for the external plane spread, which is the plane spread on the material surface. And then the second observation that they will do during the first 15 minutes is the plane spread in the cavity, or we call it internal plane spread. Okay, and then during the 16 minutes of full test period, they will observe on based on 3 testing criteria, which is mechanical performance, visible planing, and also burning debris. Okay, so this is our testing feature back in 2019. For your information, you were the first ACP supplier to do H1 test and pass H1 test. Okay. And for H414, I believe you're aware, this requirement is for building with 18 meters height and above. Okay. So in terms of coating, our ACP coating actually meet the standard of ARMA 2609, which is the highest standard, higher standard for coating performance. Okay. So usually, a coating meet and ARMA 2605 standard, it is usually 70% fluorocarbon-based coating or 70% PVF based coating. And this coating actually lasts for a minimum of 10 years. Okay. And of course, it is highly resistant to polishing, chopping, gloss loss, and also chemicals. Okay. And for your information, our coil coater, they are PPG certified. We use PPG coating for a certain coating, and our coil coater, they are certified. It is very important for you to make sure that the coil, your panel coil coater is certified applicator. Because only certified applicator, they will be able to give you the warranty letter. Okay, so in our case, we use PPG coating. Our coater is PPG certified applicator. They are well trained with PPG application, and they can provide us with PPG warranty letter. So of course, for us as a manufacturer, we will give you our manufacturing product warranty. And on top of that, we will be able to give you the warranty letter for application as well. Okay. So this is the standard colors that we have in our color chart. Currently, we have 37 colors, including solid and metallic series. And apart from the standard colors, as I showed you earlier, we can also supply essential series like wood grain, stone grain, and also marble effect, as well as hairline or brush base, simply. Okay, but of course, for certain series, the price will be slightly higher, and we will require a minimum order for the certain series. For standard colors, we don't have any MOQ. Okay. And there are some common misconceptions on ACP quality issue that I would like to share with you here. Okay. So the first issue is color tonality or color variation issue. Okay. So color variation issue may occur due to several reasons. Okay. So the first reason is because of using different batch of production for one project. So it's very important for you to make sure that when you order the, you have to order all the panels that you need in one single order from the single batch production. Or just for if you're ordering from different batch, you will have slight color difference. It's just like how, okay. And then the second issue, the second reason is improper orientation of the panel. So during your installation of the panel, you have to follow the assembly direction marked on the protective film. Okay, because if you are installing the panel at different direction, the panel will reflect light differently, and this will causing variation in the color perceived. Okay, and then the third reason is the installation timeline. So prolonged installation timeline may cause the color variation issue also due to the exposure to the environment. So panels installed at earlier stage will have slight color tone different comparing to the panel installed at the later stage due to the exposure to the environment. That's why it is very important for you to control the installation timeline for the first panel install versus the last panel install. Okay, to avoid this coloration issue. Okay. So the second issue that I want to share is bubbling and cleaning issue. So usually bubbling and cleaning may cause by improper installation and also exposure to moisture and humidity. Okay. So for your information, ACP should not be installed at a location where we'll have long-term exposure to water. Okay. So effective water drainage is very important. So that the water will not pool around at the exhibit area, causing this long exposure to the water and causing this degradation issue on the exhibit. Okay. And the third issue that I would like to share is staining and contamination. Okay. So usually staining and contamination is caused by improper usage of the sealant or silicone that we use to seal the steel gap between the panel. Okay, so selecting the right type of sealant is very important. We always encourage to go with a non-oil based or non-staining, or we call it non-leaving silicone. Okay, because if you are using oil-based sealant, the sealant may cause to this oily residue on the panel surface, and due to this will lead to this staining issue and causing the panels to look down or lose the panels shine or okay. And of course, cleaning after installation is also very important, because if you leave the stain for too long on the panel, it will be very difficult to clean it after that. Okay, so actually after the installation, you can use a soft brush away the dust, and you can prepare a mixing of warm water and also mild detergent to clean the stain. Okay, and of course, regular maintenance is also very important to what we call it, to avoid this staining issue. Okay. I think that's the end of my slide. Maybe I'll show you our product certificate and also cash report just on Okay, so this is what we have for our YCFR. And you can actually find our product in Green Pages Malaysia. Our product is listed in VPN for GPI point contribution. Okay, so EQ4 and EQ2 is actually mainly for indoor categories. Okay, and then MR3 is regional material. Because we are local manufacturer, so we can actually help in reducing environmental impact resulting from pollution. Okay. Yeah, that's the end of my slide. If you have any question, please come to us after this. We'll be at outside. We have a table outside displaying our product. Any question, you can always come to us. Okay, thank you so much. And I'll pass the mic to our main speaker today, the next one. Thank you.
Hello, sorry, I'm not architect from.
Okay, for
I'll give a short opening remarks. Fellow architects, respected friends and colleagues from the building industry, ladies and gentlemen, welcome and very good morning to each and every one of you. Selamat pagi and 大家早上好. I'm architect Anthea, new committee member of Pan Northern chapter. Today, we are very privileged to have our regular speaker, architect Chong Lee Siong, with us today in Cladding to share fire safety and building codes for excellent cladding system. Architect Chong is deeply involved in Cladding, and he has delivered numerous papers and seminars on the topic of fire safety for PAN, Jabatan Bomba, and other organizations. We are also so glad to have Ms. Lin Chong Lee, Assistant Business Development Manager of Vitally. A very thank you to Vitally for sponsoring this seminar. Today, the Apple House is definitely an encouragement for Pan Northern chapter to continue to cater to the learning needs in the building industry. We will continue our making efforts to organize more and more lectures in Cladding. As an architect, we are not only responsible for our building design, but also for its safety and functionality. Recent events involved building fires have highlighted the critical role as an architect to select and design proper cladding materials in preventing disaster happen again. This seminar aims to equip us with an understanding of fire regulation, and architecture will share its experience by presenting two real case studies on how the application of BS8414 significantly contributes to enhance the fire safety in excellent cladding system. 4 land stability points have been approved for our physical attendance. Please make sure, as usual, you sign in before the seminar and sign out in the attendance list after the seminar. For those who attending webinar, try filling the attendance with your land register name in the Google form link at the end of the webinar. There is no nickname allowed. It won't be counted for 1.5 really points. Once again, Pan Northern chapter would like to take this opportunity to thank Architect Chong Lee Siong and Ms. Lin Chong Lee for taking time from their busy schedule to be with us today. I encourage all of you today to actively participate in this session, taking notes and ask questions. Last but not least, thanks to each and every one of you for your support and making today's seminar as successful as it is. Without further ado, please join me in a warm welcome to Architect Chong Lee Siong.
Thank you so much. It's always a pleasure to come. And every time I drive across the language, I love the language. Once again, I need to plan. I say, I'm on holiday. So I come from the place to really love the land. agree, change from the environment where my office is. And probably, but I think, I'm not in any of those kinds. My office is a feature of the very near office. And very, very industrial. Where I am actually located, my office actually. So yeah, okay. That's why it's all like. I tweaked my topic of today a little bit. We are still covering the ES414, that is main topic over here, but I added in one element called passive fire stocks. I think this is very, very important. I delivered this topic detail last year, and it was quite an eye-opener because passive fire stock is something that none of you actually really know that. Not even bomba, so don't bring it up to bomba. Okay. But it is very, very important because, as I always say, a lot of times when we deal with the authorities, especially what the bomba to what the bomba to, the bomba didn't report, then the bomba allow me to do that. Actually, what the bomba want. So I keep that report, keeping that all of them understand. We have all our attention. Really, we are the people driving the industry forward. It is our design, our creativity, and our technical knowledge that is driving the industry. Driving us to design better buildings, safer buildings, buildings of better quality, buildings that serve all the functionality that is expected of our design. So it is very, very important for us to realize what is our role as an architect. That it is not so much of an asking for what you want. It really is a case of us informing bomba and for us to be educating bomba. Hey, Mr. Bomba, calling that, Mr. Bomba, I'm designing this building. This building has got this functionality. This building has got this functionality. And this building has got risk because of this, because of industrial factors, or because of the way we occupy the building. And this, Mr. Bomba, is a way of addressing those issues. Right? It is just actually informing Bomba. How are we doing it? And then Bomba will say, on what basis do you think what you just said is correct? Then you say, we refer to standards. We refer to the bylaws. And if our bylaws are inadequate, we refer to overseas standards. We refer to overseas building codes. We learn from it. We interpret from it, we interpolate from it, we adopt it, and we adapt it. And so Mr. Bomba stopped me. I'm an architect. All right. That is really our the way we do it. Just like a quick update. We are given the mandate of Bomba, finish up writing great book. It should be published by the end of the year. Don't take my word for it, just really want to say from all the reports. But the pressure is on, so Bomba saying, okay guys, it's taking too long now. Can we get it up? So yeah, we are hopefully looking at the final draft, and I personally quite slack over the last 2 months, and I think of it very, very easy for our own work. But yes, the next 2 months now we will be getting back to work. We need to get it done. So quite a few of you are actually involved in the argument on that. So yeah, good. That is what we want to do now as a action. We can all hands back together, work with you in many ways, educating more. Because they are what you want to work. Hey, you have to police by law, you police outside, you understand that kind of thing. So we're going to go straight into these 2 topics here. I'll go on to fire stocks first. Okay, before that, let me do my standard recap of uniform building bylaw standard. Yeah, just the stage. Okay, the uniform building bylaw, as you all know, is building code. I've always said it many times. We do not. Okay, all right. we do not need to learn the building bylaws to design good buildings. On the contrary, if you read the building bylaws and then you define your building based on what you understand from building bylaws, you'll all end up with square boxes, small windows. So, okay, the building bylaw is really just a law, just to ensure that whatever you do, we send it through one time through the filtering of the building bylaw, just to ensure that you're within the specific code. And the codes are all very absolute. It just gives you a lot of dimension, a lot of yes and no's. There are no gray areas by law. If there are any gray areas, it just means that the bylaw does not mention anything. Those are the gray areas. But whatever is mentioned in the bylaw is actually very absolute. You can't argue it. You can't say that have a waiver on this. Bylaw says you have to do it, you have to do it on exactly the law. Right? So this can be a bit restrictive if we do not fully understand what the purpose behind the bylaw. And in many instances, we are talking specifically about feelings and fire safety issues that are feeling from that. On many instances, some of the restrictions in the bylaws may not actually apply to all the. So they are situations where the law was, oh, the bylaw says this, so you need to do this. And you say, excuse me, my building is not under that classification, you need to do this. My building is actually here, and I need to do this. Yeah, so it is so important for us to actually know fully what are the restrictions that bylaw, what actually mean. Now, we also have this other document among the many standards available for all the different products, all the different applications and all that. We do have one overall Malaysian standard called 113. And this, I think something wrong again. And this, as standards go, standards are not a law. It is not a statutory law. Standards are a descriptive code of practice. And this is where we get all our informative descriptions of what it means to have to do certain things. It establishes normative practices and it describes performance. This is what we refer to when we come to our activity plan. Right, the bylaw is just like a summary. At the end of everything, after you talk about what you need to do and all that, okay. The law says you cannot be bigger than that, or cannot be that's all that important. So you have to read all these documents together and implement. Alright, so I'll start with fire stop. What is understanding of fire stop? Well, we are under the UBDL, right? So that will be UBDL first. What is the UBDL? What all says about fire stop? So 10133 under interpretation. Fire stop, these are the exact verbatim words from the Uniform Building Bylaws and different countries. They say fire stop means a barrier or seal which would prevent or retard the traffic flame within a cavity or around a tank of duct where it passes through a wall or floor or at the junction between elements of duct. Yeah, I'll cover everything. Fire stop means you're set off in any situation. Where is the fire stop specifically required? Okay, so we need a bylaw to cover that. UBDL 141 straight away says that wall. No openings are made in this big wall. Yeah, thanks. We know that. How about what about walls? Yeah, okay. It says the second part, nothing in this bylaw but prohibit the passage through a separating wall of a pipe if a pipe is etc. Right, so with all that. And the third subclause one is that you allow certain restrictions from what to go through the wall, but wherever it goes through, you must stop. So then again, keep asking back the question, but first we try to figure out what the fire stop, then you say, oh, you do this, and you have to be fire stop. So the question is come back to the stop is stop. Okay, and opening and separating wall, which is necessary as a means of escape from fire. Actually, what we mean is that if you have a separating wall, you need accommodation, access, not necessarily like that. Fire, right? You need opening, you need to open the door and install things like that. Very, very obvious, very So it says that if an opening and separating wall, the FRP of an element shall not be less than that required of this, which means that really what this one says is, if we are separating wall and separating wall in this instance means fire wall, right? That's the interpretation of description of what a separating wall is. It means that whatever you do, you have an open, you have a door, anything that features that wall, it must be fire spot to the same integrity as the wall as a component. Okay, so now if we think like here's what do we mean by the spot? It is actually to preserve the integrity of that component of fire. So again, the media 148 now talking about component floor. And again, it says exactly the same thing. No openings are made in any compartment wall, any compartment wall, with the exception of one or more. So again, the bylaw is slightly the same thing. And the bylaw tries to be prescriptive also, sometimes, but I don't know why. I think the next edition we will want to just set it like but that's exactly what it says. So again, the same thing, opening for ventilation, dark and turn up the fire stop. Or specifically automatic fire dampers, not less than the requirement. So again, you see similarity to what is expected. And where compartment wall forms a junction, all these junctions and other must be fire stop. Yeah, very, very, very good. So where does that bring us? So we're still asking, what can be used as a fire stop, or what do you mean as a fire stop? So now we know we have to protect all openings. So if I use, if I continue going through, I need to ensure that that opening screw has got the same fire integrity as the wall. Good. But you keep mentioning fire stop. So what exactly can I use as a fire stop? So it says any fire stop now, and here the word shall appears. Any fire stop now, if provided around a pipe of duct in a cavity, is made of a non-combustible material. Great. So a fire stop is non-combustible. Thank you. And very important. If provided around a pipe or a duct, be so constructed so as not to restrict essential thermal movement. So now we're getting somewhere. It says that first the fire stop is non-combustible. Yeah, of course, if something is supposed to stop fire, I suppose the first we actually burning in the first place. And then it also says now that the mechanical requirement here now that the fire stops are so constructed so as not to restrict essential thermal. And any fire stop formed as still at the junction of two or more elements shall be made of non-combustible material. Reiterating again the non-combustibility of material to fire stop. So any cavity in an element of structure which is continuous to the whole part of such element has the purpose of combustible material exposed to the cavity and all that, which is of a class lower than but O in the bylaw 204 shall be required of, we're talking about penalties now. And any junction, etc., with a ceiling on the roof, or generally what all of the rest of all of these say is that whenever you have differing materials coming together, or wherever you have a situation where cavity, where fire can spread through, all of that must be fire stop. Right, so here is a little additional element. Here, all of these preceding things is about fire stopping or punctuation to an element. Then together with the fire stopping at junctions, and now with the fire stopping of the three different elements, horizontal element, a vertical element, or two horizontal elements coming together at the junction, all of that must also be fire stop. Now, in other words, if you have a fire compartment, every element in the fire compartment must work in totality. Now, it cannot be a weak link in the entire fire compartment. Every single component must have the same intensity. Right. So, in terms of compartmentation, most of it is very familiar with this diagram already, but just to reiterate, this is all according to the description of bylaw. And if you have for a combustible maximum 25 millimeters, so say a PVC pipe or a bulk concrete, maximum 25 millimeter diameter. You may go through a wall, you may allow it, but for a non-combustible pipe, say ductile iron, GI, or any metallic construction, maximum 150 millimeters diameter. And in any case, all of it must be fire stop around the thing. Right, so what this one allow, generally, if you look at this, if it's a non-combustible pipe, they are saying that as part of our field of the interpretation is that this non-combustible pipe will not burn greatly. So all you need to do is to where it takes through the wall, so you need the fire source. If it's a combustible pipe, in the event that the pipe or the conduit does burn away, you will not have an opening through the wall, or rather the hole that's going to open, so through the wall, no bigger than 25 millimeters diameter. That is really what this clause is trying to say. Yeah, that in a worst case scenario, should the thing going away, the penetration that's left through the wall should not be more than 5 and go on. If you have a big duct that's going through an air duct or a full duct or something, then the bylaw actually describes the duct as automatic like that. Something that will close automatically, turn off. So this one preserves the integrity of that wall, the element, that fire damper, and must operate automatically. And this fire damper will be the fire damper. All alternatively, and this is not exactly what the bylaw describes, but alternatively using the same notation, if you wrap this entire duct within a fire-rated horizontal shaft, fire-rated closure. In other words, you are protecting the entire duct, wrapping it around in a fire-rated non-combustible enclosure, then you do not need the dampers because you'll be relying on the fire rating of the duct itself. Yeah, in the same principle as that of the non-combustible, you don't need to wrap around it. Like that, this is the concept. And here now you see that there are some things on the required FRP. Okay, the bylaw just says all these elements must be of the required FRP. Right, but once you create a situation like this is kind of the sharp situation. So you can have this material up to half the requirement. Whereas everything on the element itself would be have to be of the integrity of the same FRP required. So this require FRP for the vertical dampers, but if you're doing that shaft will be half the required FRP. But in this case. Another example, if you have a vertical shaft going through vertical penetration, so the same thing, floor to floor compartmentation, exactly the same thing. But if you're creating a vertical shaft like this, then that element is not an element of structure, it is purely an enclosure to form the shaft. So that is half the required FRP. If you have a full FRP for structure, constructing everything as a structural element, all structural elements are to form the required FRP. So yeah, I'm just pass it on immediately. So if you have something that's going to connect to all these elements, then those fire dampers may be half the required FRP. Because it's going through a shaft. And if you are having doors, then the doors may be of the required FRP. So there's always a lot of confusion. They say, oh, fire doors, they're half the FRP of the building. So say, oh, maybe the building is 2 hour FRP, fire doors are 1 FRP. No. Fire doors are supposed to be full FRP. But then I said, I'm sure somewhere there's a bylaw somewhere that says that fire doors are supposed to be half FRP. Yeah, it's only half FRP if the door is leading into a protected shaft, or if the door is opening protected passageway. The idea is this, or rather the concept of it is let's start with this one. The structure requires, let's just say 2 hours FRP. So if a fire burns over here, the structural integrity and stability must exist for maximum 2 hours. Right? So okay, so all of these elements will block it for 2 hours. If you have a protected shaft like this, so between the compartments, now you've got another intermediate shaft. So if you have an element that connects this compartment to this compartment via this element, so it will be safe to say that that's why you are allowed to have half the FRP. Because this one burns here, after 1 hour, it may burn through here, but you've got another hour of resistance back. If you have to write the new bylaws today, I wouldn't even personally bother by having this description because it just creates so much confusion. In our current project, I'm going to comment on please don't tell my client. In my current projects, I don't go to this extent of identifying which are the doors that we have at our page. Because we have problems before. There'll be so many layers or so many layers of documentation that can get us into trouble. First, that will be our own architect specifying the doors. You trust a guy that he knows exactly what he's doing. Then there'll be our draftsman or whoever it is that cleaning all these things into our documents. Do you trust the guy? Then there'll be our specifier. We see reading all the correct codes and then find the correct code and correct location on how which one is 1 hour, which one is 2 hours. And then if everything goes up here, you trust the contractor that is ordering the correct thing from the suppliers. And when the supplier delivers it to the site, do you trust the fellow who's installing the door to be bringing the correct door to the correct location? So we have so many problems. For all our projects now, I have no reference to how we require that of me. All are all for one reason. So you can't mix it up. So please don't tell my clients and please leave what I'm just saying. Anyway, that's our own problem. Alright, so what are the properties then required from a fire stop? Not only fire laws is another whole new topic of its own. Alright, so what are the properties required of a fire stop? Right, so now we refer to the standards because the bylaw stopped and we just talked earlier. So now we refer to the standards. Products and materials for fire stopping. Malaysian Standard 1183 2015. Chapter 23, Law 5, page 3. Products and materials for fire stopping. The selection of products and materials used for fire stopping should take account of the size and nature of that and any anticipated essential. Yeah, now, so you see in the bylaw, it says that every time you puncture something through, you have the fire stop around the building. And there was a clause, if you remember, it has to allow for thermal movement. Or rather, what it actually says is that the fire stop shall not restrict thermal movement. Right, so now the standards describes it in this manner. Yeah, that you have to take into account the size and nature of the gap and any anticipated differential movement. Proprietary fire stopping and sealing systems, including those devices, they are available and they may be used, provided they achieve the appropriate level of fire resistance, T=11, when tested in accordance to BS 476 Part 22 or BS BN 1631 Part 1 and a few other parts. So this is where the standards are now prescribing more than what the UBBL does. Now the UBBL actually just says two things: combustible and shall not restrict thermal movement. That's it, right? But now Malaysian standard, they bring it a little bit further. And in a case where minimum differential movement is anticipated and where the gap does not exceed 5 mm, the following fire stopping material will be used as evidence. This is in the Malaysian Standards 1183. A. Cement mortar. B. Gypsum-based plaster. And C. Cement or gypsum-based vermiculite or perlite mixes. Now, why did Malaysian Standards 1183 came down to mention these three items? Because these three elements, cement mortar, gypsum-based plaster, and cement or gypsum-based vermiculite perlite mixes, is in our schedule 7 in our UBBL of all the materials that are deemed to comply. So in the UBBL, where it says non-compatible materials for use of many other purposes and all that, these three elements is in that schedule. So Malaysian Standards MS 1183 makes reference to that, that whenever non-compatibility is mentioned, these three elements are deemed to comply. When was the last time any one of you signed around C1, C2, C3 for a fire stop material? Really, no one. Okay, that's one. Because the Uniform Building Bylaw says this. So all of us will be very, very happy not to have to find a C1, C2, C3. In fact, we're going to declare it. Why? Because if this is what we use on the site, it needs to comply. Yeah? It's not a proprietary material that is verified with a test. You don't have to. That's really what it means. Okay, so these are non-combustible materials, so it's deemed to comply, suitable for the use at a fire stop. Okay, no, it doesn't end here, of course. Okay, let's go a bit further. So fire stop in relation MS 1183, okay, fire stop 515 design in relation to fire stop. So we continue on. Now, to maintain the physical integrity of fire stopping, we enforce with or supported by non-combustible materials or materials of limited combustibility in the following circumstances. In all cases where the gap between elements that need to be fire stopped is greater than 100 this is now Malaysian standards prescribed in. Remember earlier on, Malaysian standard started off by saying that the gap between the element that's pushing through and the element of the wall shall be fire stopped. That gap, then it says we shall allow for thermal movement or mechanical movement. Now it's described it a little bit further. In cases where the gap element that needs to be fired out greater than 110, and in any other case where non-rigid or flexible materials are thermal movement, where you cannot have rigid material. Yeah, I think I've said that already, but what are the specific properties required offered by the stock? Okay, so now let's look at this. Properties required of fire stock. Okay, we already established comply. Cement mortar, different base plaster, cement or different base material. Right? Need to comply. You walk into a construction site, you do your inspections, a pipe goes through, and the contractor pictures up the opening with cement mortar or plaster, or a combination of the material different plaster. Okay, it's done. Okay, let's look at the properties. In accordance with the UDL and references to the standard, what are the properties? First, non-combustible. The key elements, are they non-combustible? No, we cannot answer that yet. Let's try and define what it means by being non-combustible first. So, EX 476 fire test on building materials and structure. Our UDL is almost the EX 476 comes to fire materials. So part 4, non-combustibility test for materials. This is 476 part 4. It is a very small scale material itself. Generally, it just consists of having a combustion chamber where you're always in two material placing. One is the base material, which is a known non-combustible material, like stone or gypsum or what. And the other material is the material that is so they will always occur in this manner. There's always a reference material and the other material. And generally, this is a very quick video I got from YouTube. Okay. So there are two materials. There will be the base material, which is a non-combustible material, and then that's what is the material that you're using. So from here, all you do is just measure it in terms of the propagation of the flame, the temperature, and the smoke and so it's a very, very, very simple test. And the criteria is very linear. It exceeds that parameter, is deemed non-combustible. Also, if it doesn't exceed the threshold, that parameter is deemed non-combustible. If it exceeds that, it's non-combustible. So it's a pass or fail kind of a test. It's either combustible or non-combustible. Nothing is between. Yeah. If you're right at the bottom, like say you can eat chana, cannot call this non-combustible. Sorry, test is the test. It's so straightforward. Now this has been used for 50, 60 years already. You can't do anything about it. But that's the limitation of the test. Okay, but never mind. The UBL still references this criteria, non-combustibility. So different mortar, different base plaster, cement or different base material like non-combustible? Yes. Because it's already embedded in the UBL team to comply. So we don't question it anymore. We don't ask for certificates anymore for this material. The next criteria, same fire resistant period as the wall or the floor. So how do we determine that? Can we use that non-combustible test to determine fire resistant period? Of course not, because that's not the criteria, that's not how the test is structured, right? So now we have to refer back to British standards again, 476. How do we determine fire resistance? So 476 part 22 is where we determine fire resistance of non-load bearing element. And this is essentially a scale test. So, this is what we use for testing of fire doors, panels, and all that. This is to test the key element, stability, integrity, and resistance of that element as fire barrier. Right? What is the characteristic of this material to prevent a fire from spreading from one compartment onto another? So this scale of test, if you look at it, is like this. It is a furnace. Oh, this is video. Okay, this is part 20 in 1.2. Determining of fire resistance of non-known bearing elements. So it is again like a full scale test. There is a furnace at the back, and there's this surface of which you intend to test the material. So you have to construct this entire surface with the material, and you put in the furnace, you light up the fire behind it, and put in all the thermal controls, and then measure the fire integrity. For this one is not for load bearing, so we only measure the integrity of the material, we don't measure the stability. And if you want, they also measure the insulative values. Right, so this is it. So part 22 is testing a material in this manner. So the question is, our topic today is fire stops. How do you different plaster or how do you test your fire stop material using this method? Generally, you can't. Okay. The fire stop, we're talking about fire stop, sweeping some material around the pipe. So how do you determine the fire rating of material? Yes, for you can't. We can't build an entire wall out of the fire stopping material and test it in this manner. Because it just doesn't work. Okay, so this is the wrong test. We can't do it. That's no. Oh, fast forwarding, I'm sorry, I'm just trying to take to the next slide. Oh yeah. Oh, okay, great, thank you. So same fire with period and appear on the wall floor. For these three materials, can it actually be transferred to given fire resistance rating period? Questionable. We are not able to determine because we don't have a suitable test to do it. And allowing for thermal movement or physical movement. Well, we all know cement mortar, once it cures and hardens, it's kind of rigid now. So I don't think the material itself would have any elasticity for it to accommodate thermal movement. So anyway, it's questionable. And how far can cement mortar fill that gap? The Malaysian standard probably say up to 100 millimeters. Anything beyond that, you better have some other means of structural support. Right? So cement mortar is probably 850 millimeters into the gap, allowing for the whole of physical movement. Okay, it's very, very questionable. We are not in a position to be able to. Right? So, who is the principal committee person signing off on this building, saying that it's complying with all the rules and regulations? Yeah, we are not in the position to determine items 2, 3, and 4. Now, if we just specify the 3 materials of it. So, where do we go from here? Now, this is where we would have to rely on what has already been practiced internationally, and particularly with EN standards and ASTM. Right, in particular, for Firefox, the EN 1366, Part 3, Part 4, and EN 1364. Now, here is where the standards are written very, very specifically for the nature of the fire stocks. Very, very specifically for all penetration to pipes, cables, or any services will be tested with EN 1366 Part 2 or ASTM 381. For anything that deals with the joining of walls, all of these are described in the by the way. It will be tested in EN 1364 and the accompanying ASTM. And likewise for gaps between curtain wall and structural floor, this is relevant to EN 414. It will be tested to EN 1364 Part 2. Yeah, so these are all the standards, and this one obviously is way beyond our certification if you chicken class and all that. If you think we are in the position, in our specifications now, if we find that any of our design where there are situations that require fire stop, if it really, really goes beyond just this element where the fire stop that is specifying requires confirmation of, and where it requires allowances for movements, and where it requires structural support where the gap of beyond 100 millimeters, we cannot confidently rely on this key. We must really consider going for a plastic material that does comply with these standards. These are the important things. And since our Malaysian UBDO doesn't specifically direct us to this, it doesn't. It stopped at what I've just mentioned. Need to comply with something, then after, it's done. Yeah. So, but it's our responsibility, I believe, that whenever we do these things, we should recognize and should know what are the elements that have to go into our thing for the proper fire stop to be implemented. So I will share with you an experience on our project we conducted about 2 years ago, where we specifically took on this is architect being very easy for the just going beyond what we're supposed to do. Thankfully, the client is eager to go to our own devices. They didn't bother us too much. When we first started the tendering documentation for this thing, we told the engineers that we will want to look after fire stopping. We took it away from the engineers because most of the stuff are done by the engineers. Actually, it's not true. Engineers don't even look at the fire stop. What the engineers do is that they rely on eventual subcontractors or the eventual continuing utility suppliers to do the fire stop. Because all they do is write it in the clauses. where you have a situation, this one goes through, you check with the architect, if that one is on your wall, okay, you have to provide a fire stop. So they tell it in that manner, but for this one, we're going to be very easy for the line, we are so we put it off with engineers, we put everyone, right? All fire stops, engineers, you refer to a provisional fund to be managed by. So right at the start, we provided a the information is there. We are using this document with this project. So we took the opportunity for us to learn very, very quickly all the technical details fire stopping and how do we document it, how do we get everyone on board. And so that's what we did. So I will share with you our experience of going through on how we design fire stops using building information modeling in the company. So step one, of course, we design on. So we start with designing. So with the documentation, the first thing we did was that again, when we do design, we always want to rely on engineers first. Engineers need given design. Engineers please tell us about the concept, relation, diagrams, and all that. Engineers please tell us how big a room you want from the genset room or whatever. No lah, because engineers say architect do something first lah. You tell me how big is the plot area lah. You tell me what I said lah. Then I think time over here lah. It's always great for you to read the kind of thing. So in building documentation, not way one. So we always want to get to about the TV lah, we just want to pick the lead. So we come up with a model like this first, a very basic method model. Immediately we have all the elements, the structure elements in place. Then we put place holdings. All these transparent boxes are our place holding, and particularly these elements, the vertical risers, the areas that we allocate for the engineers to work on. We even split it up, split up all the different activities, between mechanical, electrical, between the hydraulics, between the air movement, air handling systems. So we split it all up and we allocate place things for the engineers. So without the engineer, I as the architect, I determine how I'm going to be. These are places you working. Then that way is very easy. So the engineers are working on all the different methods, they have own place holding working. So we provide them question from there. Well, we start with placeholders and design model. Then from there, as engineer professor at work with professors, the placeholders are gradually bringing engineering elements that the design develops. And this is when you start to in their components. And the placeholding that we allocated earlier for all these risers and the corridor for the calculation, the engineer will then fill it in. And that is where the engineer will say, Mr. Architect, the space is provided me way, way, way too small. I don't know anything about it. Can you say, oh, you need the bigger space, you did okay. I will then divide it as space. And then it is top space. Or sometimes we surprise ourselves and we like something and okay, so I'm giving you this space for your drafting. What's the size of the table you want? Oh, I got one table, just for the size of the sheet. Then we say, can you do that? Okay, good. I will then make the allocation to use the spaces for that. So yes, we're very interactive. We have to understand what they're doing. Generally, they want to control their plan. So from here, once we got all the space holding with space holding elements developed, then we come a little bit more fine. Then we able to identify and go down to this level where we will identify precisely where these things are going through firewalls, where they're going through fire compartments. Generally, we talk about fire stops. So where these elements require fire stops. So this one is then stop. So engineering element develop individual component applications. Then on to step 2. Step two is where we start practice part. Once you identify where everything is supposed to go, where all the penetrations are, this is then we will refer suppliers, we refer the people in the industry. We will want to start looking at what are the available materials, what elements are necessary, right? Standards, and how do we apply those elements, what are the applications, what are the communications. So from there, you do up a chart first, which are the elements and which are the components that we would eventually require. Right, and then this is where it starts. So now I ask people are able to send them around to 1, 2, 3, CP for fire stock. Actually, it is available, even though we do not specifically according to the EN standards of ASTM, but it is available because they will go to Bomba and they will then send them with the actually test result, and Bomba will be very happy to certify it, because Bomba also learns from it now. They issue the first and all that. Right, but this is where we then have to know very specifically what are the materials, the tool, and what is it for. Right, so you always know the name and type of the material, on the test standards that it fits our criteria, know who the manufacturer supplier is, know what is the qualifying rating, and meet all the test reports. That's very important. But we need that importantly, we can assure us that the material that is specified is actually from first line for what we want to do. This is only just one cert. Altogether, we have about, I think, 7, 8 different certs because we use 8 different components in our building. So this is just one example. Then once we determine that, and then essentially, this is the hardwork of because this. So we've got our building design. We identified the areas where you need the fire stops. We found all the necessary certified components that we can use. So now the hard work is how in the world we document all of this to be precise onto where this thing has to go to where, each thing has to go to where and all. And this is where Tara will be able to tell you a bit. If you take her out for lunch, she will tell you how to become our marketing and teaching. So this is really the so far. So we have to go through every single corner of the building. We have to identify every single penetration, cluster them together, identify where all these elements are, try to match it to what we think we know of the product that we're trying to specify, and all kinds of things. So generally what it means is that this is hard work. You have to schedule each fire stop by type quantity. Based on the just talk about time, so that designing everything to be there. But to identify these things, we literally have to walk through the model. So I suppose in a way it's really helping us a lot. We're not looking at 2D plans, but we actually have to walk through every single model, straight to find them up, and then one spot there. So we identify the spot and we label it. Things like this. So from here, we even start to identify, we even start to model of it, what the component is supposed to look like, so that we give ourselves a reference. Then from there, we generate, not from the bill of material, we generate this whole tabulation by the location, by the unique ID of that element, the product name and type, the dimension, the size, the type of penetration, and of course the quantities available for this, the quantities. Immediately we can do everything in one go. So after the hard work, this is the result, and we find that it's actually very, very good. Then the fourth step is of course the construction. Once we hand all these documents to the contractor, good, we put the liability on, and now you got the result. So generally This is what we do. So these are the results. You can see that areas that we using sealants. This is purely for fire rating, and this one accommodates a certain degree of thermal. Generally, all is a rigid pipe going through a rigid opening. Yeah, and this is very sealant. So these are just called sealants in various forms. Some of them, depending on how we do the opening, some openings are just called through. Some openings we actually got steam in before we open it to allow. So we cannot get despite the best of being, we can design anything, but construction, they're always. So there's no way we could get the pipe to go in exactly, so we always design top openings. And this is where the flexibility of sealants comes in between the lanes, and you can see that there's a big difference in terms of the centrality of the region. So these are generally sealants. Then we have collars. These are the ones for multiple types. Now, these are intermissile material. The intermissile material within this thing. So these are multiple types. In any class. Now we will end up using a collar. So when this thing burns, remember what the UVL says? It is a combustible pipe and limited between 5 mm. So in the situation like that, I really not comply with it. Yeah, but the intention is that we must proper fire stopping. This is where by identifying this kind of fire stops, we can have combustible pipe far bigger than 25 mm. Yeah, these collars work in a way that when the intermissile material is heated up and when this pipe starts to melt, the collar will kind of in the tip. They just expand and shut off. And that is the intention, like how it is. And all of these. Then there are mixed block. Mixed block are effectively they are sealants, but it comes like a block of plastic. So it makes it a lot easier for opening, but like this kind of an opening, sure a bit more example, like this kind of openings when for cable trays or multiple cables going through, there's no way we could organize the solving through single one. We have to look at all of the reality. So the one cluster of things going through. And we think a lot of times they're subject to alterations and additional height or even changing of those cable over the life of the thing. So this is where we use blocks. We call it mixed block of different density for different purposes. We call it plasticity. So you mold them, you cut them around the cables, and when you do have to repair any of them, you can break open the block, redo all the cables, and then you can attach it back. Yeah, especially like things like this. We work on both vertically and horizontally. Now, the next one will be composite. Now, this one fulfills the second Malaysian standard criteria on the structural integrity or structural stability of these fire stops. For situations like this, fire stops are like so big, like this one here, the slab is casted with this big opening. Because there's no way you could have all individually to allow for each of these. So we make a full opening like that. And after all of this is done, we have to come up with the composite construction, whereby there is an intermissile material that forms a very steel, but there also this top metal plate that you see is purely for the surface protection, that you don't step on it and push holes into the fire steel. But at the bottom, from the bottom of from the side, you can see there are these trays. These additional trays here we then support the metal plate, and this is the thing that holding it together. This is the reinforcement that mentioned in the these are the structural reinforcements to hold the material in place. For these very big white buildings. So generally these constructions are called comprehensive. Like this one here. The slab opening is all the way here. Right, then there's this tray. This is the upper tray for the protection on the surface, and below is another tray holding the material. And all of these are reconstructible. In other words, 10 years down the line, we need to put in new cable or we need to add additional things here. We just remove the tray from below, break off all the insulation, we not talking about this raw materials, lay in new cable, and we do all that. So good. So after that, then the not so hard work after this is actually the extraction. Why is it not so hard work? Because if I'm a higher contractor, they got you in the past hour and spot one mistake. I said, I'm walking home now, you better fix it first. Call me again, finish. So it's a little easier. We push the liability and responsibility to contractor. So in extraction, when we talk about this, and this is more crucial, we will have to, because in our design, we really got a big documentation. The big documentation has really identified clusters of where we understand the location, the size, the material, and all these things. The intention of this project was that we are supposed to bring it to we are supposed to bring it to November. We are supposed to be bringing it to LOD 600. Okay, 600 means you have the full digital documentation for the purposes of winter maintenance. Right, so the intention, the original intention was that all of these tags are supposed to be QR codes. So once you register in and QR code will be generated for each of these. So in the future, someone has come along and open up this and redo a new thing. With the QR code, they will be able to know the exact classification of what's going in here. When was the last time it was touched? Who was last person to touch it? And who was last person to sign it off? And what was the evidence it was supposed to be there? But for this situation, our supplier at that time were not ready with the QR code, so we ended up with the manual tagging. But all these numbers and all that matches our big documentation. So just one step short of the full digital tagging. But eventually, this is end result that we documented that. Of course, Bomba doesn't even go to this level of detail when it comes to the fact okay, if you see the vein, they see all the veins marking the building itself, and then we submit the vein file of C1, C2, C3, and all the figures to them. Just correcting. But yeah, you're the guy who takes sign on the document, so you might think, what you're doing. So yeah, these are the tags on eventually, and when we handle over this first time in the history of the company, the architect delivered to them full documentation and full packaging for the implement application. So that's very good. We're very happy with that. It's a contains the unique. Okay, then what do we do in step 6? This is where we have to do the barang certification law. So you have C1, C2, C3. We have to do this for every single one of the stuff I think we get 6, 7, I think 7 or 8. So we have 7 or 8 types of intentions of my form. And from there, we have just ensure that all this information match what we have in our document. And so why you can sign, we follow the sign. Finally, the architect Okay, before I go on to the step 7, now let's go into external cladding. How much have we got? Okay, perfect.
So, I think there's two parts, right? This is like a part of the part, so before we move to the second part, maybe we take a 2 minute break, so that thing is quite a bit. Take a break and then we come back to, and we find,
What, it's starting to break up already, is it?
the part that is simply because it's so down. Right? So that we can finish in time, and I think we have probably a lot of question. Okay. Oh, yeah. Okay. Are you planning? Okay, I think some are still lost and people who's voting.
Okay, great. Now we have finished with the main talk. Now we come to what is supposed to be the main topic today. External cladding. What time I talk?
2 hours.
2 hours.
1 hour.
1 hour plus.
45 minutes. Or get 15 minutes for Q&A.
Yeah, we need to kind of. Okay, I think I should be able to finish it now for the time. Okay, I think most people are here. So external cladding system. Not just we've seen this before, maybe, but let me recap it. Grenfell Tower, London, built 1974. A very nice brutalist architecture, complete recently infill windows. New facade cladding 2016. They are trying to make a building look better. Okay. In June 2017, they really changed the landscape of the town of Grenfell due to the fire. Probably the model in Milan. There is very beautiful building. It's also a residential apartment complex built in 2011. And in August 2021, just before it reached its 10th birthday, again, it was totally engulfed and burned down. The commonality in these two buildings and South Fire one probably can this Milan fire. In Grenfell, fire actually started as a refrigerator, as a faulty refrigerator in 7th floor, I think. It was on the apartment on 7th floor. The refrigerator burned, the whole refrigerator caught fire. The alarm was raised, and the fireman actually came, entered the apartment, looked at the refrigerator and declared that fire has been put out. They say, okay, fire is out. Everyone safe. That the refrigerator is put out, entered the apartment, and the refrigerator declared it's no longer on fire. But what actually happened was that the fire, the initial fire, started from the refrigerator, broke out through the window, kitchen window. And it started at the ignition of external cladding. The new external cladding, less than 1 year old, the building. This one, this Iran fire, it started with the air conditioning fault on an external balcony on the top floor. I think this one was the floor. So it started from faulty air conditioning unit on the external balcony on the top floor. So when it first started with the refrigerator fire on the 7th floor, burning up, and the other started with the air conditioning unit on fire on the top floor at the balcony. So the commonality of these two fires is actually how the fire, extent of fire will be. So both of these can be considered fire breaking out from within the building. It wasn't an external source fire. It wasn't that it wasn't an arson coming along and a fire to external start. It was a fire from internal source. A refrigerator in the kitchen, fire burning out through the window. And one air conditioning unit in the balcony burning out. And it is at the top floor, right? And it burned out and due to a cladding. Okay, so the commonality of this is the location of fire. I'll show you this video now. I think the last time I tried to show this video, and this is a very, very typical apartment fire. You see it even in Malaysia, you see they have this situation on the fire apartment like this. Generally, it is burning out of an apartment in the building. So see, here the fire, well, it hasn't reached flat over yet. The fire has just arrived. And okay, I can just pause here for a moment. You can see that the fire is not reached flat over yet. Generally, the content of the apartment by now would have been affected, but it's not reached flat over. So what we have here is immediate flame that's probably breaking out through a balcony door. And it's burning through. This is a canvas. Okay. So the fire is burning through, the hot smoke is burning through the canvas, and but the canvas is not exactly fire at the moment. It's just burning and turning into carbon and now as the fire is burning, we reach this situation. So the fire is now burning. You can see the effect of the smoke going up. This canopy is lacking because of all the thermal pressure, very, very hot smoke going up. Now you see what happened. So now you actually see flames coming out. Right? So this one indicates that the apartment has reached flat over. The entire apartment is now like an oven. Everything in there has now reached a degree of possibility. The entire oven, the entire apartment is totally flooded. Okay, the chicken is totally burned, it's not longer roasted, it's actually going to carbon already. So this is a phenomenon known as flashover. I can see that the firemen they are putting on the fire alarm. They are just saying that they see the situation, they understand the situation. They will have really gone into the building. The first responders have gone into the building because you can see the resident actually was brought out to the street and they are already on the street. So a situation like this is absolutely flashover. There's nothing you can do. Yeah, absolutely, you cannot put out the fire. You want the fire to just keep burning, still things that's in the apartment, and eventually you want the fire to just pay on its own. Right? What you say, what is actually the body of the moment. Right, you look at the firemen now they finally did cut the hydrant onto the fire pumps, and they're now shooting water up there. But where are they shooting? They're all shooting the water around the side of the building, particularly at the top of the side. No point whatsoever trying to shoot water straight into the fire because flight over now means that the temperature is 100 degrees. The water will have evaporated even before they went near the fire. So what they're doing is cooling down the temperature to prevent the spread of fire. So you can see now the canvas balcony are now has burned through completely. They have been consumed. All we see are the metal frames hanging down. Right? And the apartment all seems to be reasonably intact. They will have a lot of smoke infiltration for sure, but they don't feel that it's caught fire. And the apartments on both sides, the clothes that are being hanging on the balcony still remain not burned yet. Oh, this is the resident, so they did manage to rescue him out of the apartment. Just pause here for another moment. Let's analyze the situation. So you can see now the apartment is definitely flexible already, but it's gone beyond the peak now. The fire is just consuming what's left to consume. This part here you can see where the original locale is really nothing left to burn, but become all covered in the. So see the heat is all around here. The open flames are leaping out at the top. Hot smoke is being circulated. But generally, I think the is very intense. And the fire contained within the one world. So we reach the final bit during the flame out. Fire are really nice too. I think you can keep it. But they're professional, they know exactly what to do. So this is called the flame out situation now. So the fire has taken already, no more fuel inside. So all you're left with the embers and the latent heat that really generated. And the smoke starting to find already, generally it's just a lot of steam or maybe no more carbon because what has been consumed has already been consumed. So so that's the situation. So here we got a full-fledged flash over in an apartment building burning. And after about I think about 20 over minutes, it's played out, and the only real damage is the apartment itself. Why is it that in this when it fell, one little refrigerator fire brought down the entire building? Why is it that in Iran, one air conditioning fire on the balcony on the top floor brought down the entire building? So that's the question today. And we know the complete law of external cladding systems. Okay, we have the answer. It's okay. So in okay, Now, in the UBDL, all our way before we have the 414, way before Grenfell, we already have provision for this, the prevention of fire spread from one compartment to another, especially floor, and that's the reason why we have compartmentation. That's the reason why there are volume limits for all the purpose groups in the building, with the exception of officers and basic assembly. All other purpose groups have a volume limits to the fire compartment, and floor to floor we got limits and all that. So the UEL in clause 149, we already have this provision of vertical and horizontal barriers. And so if the fire breaks out here, fire has been in is the reverse of pouring water from pouring tea from the teapot. We all have the same problem. When you pour tea from the teapot, if you're a little bit slower, or some silly reason, the tea leaks back at the spout and then it starts drinking you and you say, what? I'm getting more water on the table than into the teacup. So fire is the opposite of water, water becomes fire boils water. So if you flip the situation around, fire moves upwards. So it reacts in much the same way. It likes to become surface tension thingy. When the fire burns up, you want to bring it back into the building. So this is where we have this in the UBDL, we have this vertical and horizontal area situation. Yeah, where the intention is to deflect the fire away from the surface of the building to prevent it from coming back into the building. In the video that we saw just now, that's exactly what happened. They do have this very straight vertical beams, so the fire has a chance to not link back into the building. Of course, smoke in, yeah, but the effect that don't blade linking back into the building. And so this is really effective. I believe all of us are doing this, right? Yes. I'm going fast forward to after the Grenfell fire, Grenfell of 2017. So immediately the whole industry worldwide all happened. But around August 2021, Bomba issued a circular to officially mandate the implementation of the EFA 414. At that time, we actually already done the necessary amendments to reform building bylaw amendment 221. Yeah, but we had to wait for Parliament to accept it. So Parliament did not accept it until December 2021. But Bomba couldn't wait for the date. They said that must issue out. So this is the circular that they issued. Essentially, it's saying exactly the same thing. Now, all buildings will be because of height with external cladding, all external cladding are subjected to the EFA 414, and anything below 18 meters in height would be subjected to a Class 4 certification. And this is between the old UBDL 1984 and 2021. So previously, all it says is this: if your building is for any cladding below 18 meters, then there are prescriptions. What you can do, okay, you use this material, you use the paper has space how far apart and all that. Very descriptive as to what you can use as cladding or as a wall surface. Whereas if it's anything above 18 meters, you comply with Class 4. That is 1984, prior to 2021. That's it. So we are not actually exactly guilty because we are in full compliance with the bylaw and what we do. But however, now in 2021, it is anything below 18 meters, you must comply with Class 4. In other words, all building claddings now, all external cladding must be Class 4. That will not be Class 4. But If you're building more than 50 meters, then you need full seal testing to comply with BS 8414. So that is the new classification. So we then just clarify again. Generally, if you're less than 2 meters from the boundary, or if you're more than 50 meters in height, you comply with BS 8414. So less than 2 meters from boundary, or more than 50 meters, comply with BS 8414. If you're more than 2 meters from the boundary, and you're less than 80 meters in height, then you must have 4. Okay, so it's kind of straightforward in a sense. Now, I think this is where the real understanding of the company, what is actually class 4. There are actually no standards called class 4. There's no grading known as class 4 in anywhere. Let's go to. Okay, first I have to show you. Chong Lee mentioned this morning already on 476 part 6 and part 7. But let's look at it. Try to look at the video. Okay, first warning. Not warning. This video is very boring. It doesn't show you anything much. Thankfully, it only a few seconds. Okay. Showing you what BS 476 part 6 thing looks like. So this is the material that they are putting it in this frame, and they are bolting it onto this little furnace. You say, huh? Furnace? Furnace is supposed to be a giant room where it's not room. And that's it. That's not it is. So the material is in this way. It's facing the little Bunsen burner on the other side. And then they have the smoke holes, and they have the measurement of smoke and all that. That's it, you know. So what I'm saying is, BS 476 part 6 is really a testing of a very small sample of material. As you see, that frame standard size is about the size of an A4 paper. Right? And it is only measured Bunsen burner flame on the surface. And it's measuring the fire propagation via the thermocouples and via the measurement of smoke and steam. It's just that, and then you go through a very complex formula that is meant to engineer complex formulas because you know architects are very good at maths. So we don't question them. So difficult that index. Okay, this one you need index of 6 or below. So it doesn't matter, we want to question it. What we see that very, very small sample, and you're only exposing one side to a burner, Bunsen, and they're just getting the same configuration. All of that have been practiced an index of the propagation, right? The part 7 now this one is a little bit more visible, and I think it's something that okay, at least the architect can say, I know what this is. The no time cheat me. So let me show you the video. This is part 7, surface spread of flame test. So it starts with the sample that you're testing. The sample needs to be fixed. And those markings, is standard template that you must mark sample. And you expose it to a heated surface at 90 degree angle. This is a heated surface at a 90 degree angle. And there's a little Bunsen burner there that shoots the flame. That little Bunsen burner, you can see that? It shoots the flame at the corner. And the whole purpose of this test is to measure the spread of the flames in that direction. And the marking on the Bunsen, the marking on the okay, so the markings on this on the set the flame is spread at a low temperature. And over the fixed period of time, they just measure or they observe how far has the flame spread. And these are all the markings, these are the thresholds. So if the flame does not spread beyond that line, the first line within that 1.5 to 10 minutes. Yeah. So short, you know, and the sample is so small. The sample is the sample is just that big. It's a very small sample. And we are only the exposure to the first, and because it's spread of flame in this person. So yeah, that's really okay, so that's really it. You can't help. Okay. Okay, great. Just go back here a bit. So that is really all the mentioned. So now we've got two steps. We've got part stage, which is on the propagation index, whatever the index means, but it's about how what is the likelihood of the material propagating flames when it's on fire. First, it's actual fire, if it's actual fire doesn't get, but the one will be determined in the non-combustibility test. One earlier on, part 4 is non-combustible. So the material is either you're combustible or you're non-combustible. If you're non-combustible, don't have to check this type of baby because it's deemed non-combustible. Right? But if you happen to be thrown into the non-combustible degree, then okay, you may need to contact it with further tests like this. So part 6, propagation, and part 7, spread of flame. So from these two, now we refer back to the UBBL. So the UBBL says any reference to being class O shall be construed as the requirement that so this class O reference is actually a UBBL reference. Now, of course, the UBBL is not created in Malaysia. It is actually amalgamation of previous British ordinances. Now the UBBL, the first UBBL only came out in 1984, and we have to thank our local architect, Lu. He was really the lead person at that time to bring us to having a uniform building bylaw. But only 1984, not that long ago. Okay, but it really wasn't that long ago. Okay, 1984 was when I first started my first year in education. Also, I'm not that old, so really not that long ago. So only 1984 we still got first uniform. But all of these were taken a lot of references on old British stuff, which is why we inherited the Air Force at the same time. So at that time, the description of class O is actually not in the standard, but it is a description of requirement embedded in the bylaws of the British ordinances. So class O shall mean that the material is non-combustible. So back to what we said this earlier part of the morning, in terms of fire stopping shall be non-combustible. Full stop. So it's different class. Vermiculite with the mix with the gypsum or whatever, that 3 elements need to comply. Which is the same reason why we don't bother even questioning our the most common facade in our buildings is actually plaster and cream buildings. That's why we never question it. Because it's non-combustible. We need to comply. Just like fire in the video, the building is made of reinforced concrete and masonry walls. The fire doesn't spread. You can have a full flash over in the apartment building, the fire is coming out of the building, but the fire does not spread. Because the surfaces are all non-combustible. The fire will spread by leaking into the opening of the unit, which is why we need a fire barriers. Right, but fire does not spread. Okay. So any reference to surface, so the moment it's non-combustible, it is considered class. Right? Or there's always an or. The surface material is bonded to a substrate, etc., etc., shall be tested in accordance with the BS476 part 7 and part 6 having an index of performance or exceeding. I have no idea how to arrive at all these, but we just have to accept that when they go to test, somehow the engineers are able to calculate stuff. So that's familiar. And so it is actually that's really what it says. So class O is really first non-combustible, or we get part 7 class 1 and part 6 having a component in this not more than 6. Okay, and this is part 7 class 1. So that will be the plane straight in order to qualify as class. So in summary, what is class O? Class O is not a fire test application, but its definition is to be so it is to achieve class 1 fire rating class 3. And that's straight from part 6 of so this is actually if they have a material coming and say we pass class like vitally the material, they have a class application, they will go through these 2 tests. To determine this classification. Alright, so external cladding, very quickly to recap. Now we got 2 classifications of external cladding. Below 80 meters, material, surface material class 4. Above 80 meters, you need ESP 414. And to recap it, class 4 means the material come through the testing, part 6 and part 7, shielding this indicator. And if the material has not gone through this testing, it must be a deemed to comply material, i.e., non-combustible. So all the masonry building, plaster and paint, no components. You can't find any element to find out the C1 and C2. Right? For basically. Okay, so what exactly is ESP 414 now? Just to clarify again, the BS476 testing is only one single material. I just remember that. Part 6 and part 7, and even the earlier one comes from part 4. You've seen from the video. Part 4 is one single material that you see. You just come to the truth of that science. One single material. So if you're testing gypsum plaster, it's one chip of gypsum plaster. If you're testing aluminium, it's one solid cube on aluminium. If you're testing PIR, you'll be one cube of PIR. And that is part 4 for another part. Part 6, it is, as you can see, one block of material with a surface exposing to the plane being the surface being connected. So if you're coming up with a laminate material, this test does not in any way have the other layers. It only has the performance of the first surface layer that is exposed to the plane. Exactly the same in part 7. Straight on plane. It doesn't matter whether your material is 3 layer, 4 layer, 5 layer, 10 layer, it doesn't matter. The plane is only shot onto the surface and it only is the straight of plane of your surface. material. That is all. I hope you understand that. Class O is purely a test on the characteristics of that single material. Whereas the DSA 414, it is not a classification of single material. It is a classification of the entire construction system of the company. So, cladding is no introduction to the DSA 414 method. The primary simulation of this is that of a fire breaking out of an opening. That is the entire premise of this test. It's purely that. So from the video you can see the fire in an apartment building. If the surface cladding material is non-combustible, the fire stays within the compartment. In the case of Grenfell and in the case of Milan, the fire breaking out from inside the building, either at the balcony or in the kitchen, reaching the external cladding and brought down the whole building. Yeah? So DSA 414 is the test is to simulate what happens if you got a fire breaking out of an opening, such as window or doorway, unconstructed opening. How does the cladding respond to that? That is what we have to focus on. And the next method is to evaluate different of their data. And the test is to document the fire propagation response of a complete cladding system. And it does not cover the performance of doors, windows, or balconies. It is only to test the performance of this one element called external wall cladding. Okay. So the DSA 414 comes in two parts, and part one is part two. So why so complicated? But it's necessary. We really need to have all the definition. So part one is the external wall is supported by or backed by masonry structure. Now, what is B here? Masonry here just means just that, not remember the thing about unremarkable. That's really all it is. If you supported by a masonry structure, masonry in this case also means say a complete shear wall, a complete structure. That means the actual wall itself is of a masonry construction, or more precisely of non-combustible construction, right? Then you go for part one. You go for part two, it is supported by a structural steel frame, but here I will extend it a little bit. It is that you go for part two if you do not actually have a non-combustible wall acting as a primary wall. So in other words, if your cladding is the wall in itself, and it is not being combustible, or any of the components there are not being non-combustible, then it will be subjected to DSA 414 part 2. Okay, I think we've seen all of this already. This is the path. Okay, let's look at the criteria. First one is external fire spread. We measure the external fire spread over a certain time, and with a protocol that fixed intervals to measure the spread of the external fire. It measures the internal fire spread, and it has visible flaming. That means we look at the visible flame that we can observe. That's 1, 2, and 3. And then that's 4 and 5, which is mechanical performance. How stable is the entire structure? Does it have to peel off? Does it have to form? Or worse, does it have to collapse on you during the fire? And 5, burning debris and full fires. If the structure is still standing up, it's not collapsing, but what are the debris that's falling down? What are all the various components that burn off and fall down? Then for part 2, there's the additional criteria number 6, which is called system burn through. This one only applies to part 2 test. Right? Part 1 is from 1 to 5. Part 2 is 1 to 5 plus 6. It's called system burn through. Okay, do we want to see this video? This is the video of the civil testing facility. Okay, I'm going to bring this about that. More of a civil promotional video. That is the size of the entire weight. So all these are standard. This is the prior, the burning fire, and the intensity of fire or fire load is controlled. The density of timber making up this fire is 100% controlled. That means every single tank will use exactly the same amount of density. And actually also because this one piece of timber, so Malaysia will have to import is a piece of pine wood. I don't know why they did not find a local equivalent, but for the purposes of standardization across the entire world, several about so we have to import pine wood just for that purpose. And yeah, with that density, how we put it. So generally, you can see that this is a simulation of a fire breaking out of an unprotected opening. That is a simulation. Okay, let's move on. Okay, whoops. Okay, this is an example of the EXO414 part 2 test. So observe the difference. On the front, it looks exactly the same. This is the simulated opening, or when the fire is breaking out of an unprotected opening. See the fire is breaking out of the unprotected opening and then leaking back into the frame. Alright, now this is part 2. So part 2 is you can see that there's no masonry wall. So part 2 is for a cladding system whereby the cladding system is wall. You are not putting cladding as skin over your very non-combustible wall. Yeah, your cladding system is wall. That's it. If you got no wall, you put your cladding system over as a wall, that one you go for part 2 test. Okay, and just to emphasize on the material. So regardless of part 1 or part 2, two main criteria of one of the criteria. One is the visual flame zone. The flames coming out of this predetermined opening with this particular fire load, the flame cannot be seen to be going outside the surface of this sample. If the flame burns sideways like this, it fails immediately. They'll put a stop to the test. And following the things falling off. Of course, if the whole system, the whole structure falls off, we really feel no question about that. But if the structure falls, and you have all these falling debris that just accumulate down here, it cannot fall out of this zone. Zone will be demarcated by the width of this cladding and the depth of this L angle that's coming up here. So the falling debris cannot fall outside the peak zone. Right? And the thing that falls within the peak zone also cannot exceed every element cannot exceed about 600 millimeters in length, and it cannot exceed 200 grams in weight. So if it happens to fall on you, it's 200 grams lah, it should not cost you too big of a headache to fix you. It's going to be an idea. So 200 grams, what is 200 grams? 200 grams of a package of chip more biscuits. 200 grams, if you buy a packet of potato chips. You buy a packet of potato chips, that's 200 grams. So if it hits our head, okay, you'll survive. So, here, now, we have to understand how precisely what the difference between part 1 and part 2 test, because it cannot be used interchangeably, whatever you have here. So, this is the testing way. It starts off this way. If you wait for part 1 test, the facility will have this chamber that you see in the video. That is the clip, and the clip student will assemble it. You have to pay them up. Pay them, it comes with they will assemble this clip for you in the precise with the important angle and the precise density. Then there will be this wall. This is wall, like a multiple wall. In BSA 414, everything exactly the same, but there will be no wall, but they give you a lot of flow frames for you to attach your system to. So the structural frame, so these elements here will not be part of the test. We are not testing the integrity of these components, but these are the basic components forming the testing with for your components. Right? So these are not relevant tests. If the brick wall falls down, okay, it is failure of test, not failure of material. Likewise, if for some reason this steel bend and form also in the output, and they have a sample and start again, because that's a problem then with the brick. So the components that come in here, then these are then all the components that form the piece. So you'll probably have a framing that will be attaching onto the masonry wall. You'll have the actual cladding, actual skin. In between them, you probably have the insulation or whatever else. Likewise, the same, it doesn't seem to be a bit different. I've still got the frame and cladding, and I've still got the cladding. What's the difference then between BSA 414 and part 1 and part 2? It will be dense. Because you're testing that as wall, it is not only just it needs to have an internal skin, or what you would mark as if you say cladding one single skin, but it's coming okay. Right? Yes, 414 does not components. All it just says is that in this situation, you don't have wall. So where is the wall? So if the wall is staying of 2 or 3 skins, you have then normally what's the thickness skin. If your wall happens to be, if your structure happens to be just like that, you see that's the system. I'm just going to bring a piece of material, I'm going to wrap it around the building, single skin. Okay, fine. You tap it to the BSA 414 part 2 now. And then you nominate this as external skin. This is also the internal skin. So the standards does not in any way describe how to construct or how to scale the system. It's entirely up to you. It is the performance criteria that I'll describe later that will whether you actually want to do this or not. Because you have to need. So okay, that's generally usually where we you build a cladding system, the installation of it and all that. You recently wall with the wall, and in this part 2, you usually have a standard in and out the skin. And very, very important. One of the original simulation again that we are doing for 414, what scenario are we actually testing for? We are testing for the performance of cladding in a situation where the fire breaks out from an unprotected window or unprotected opening on the door of the wall, right? Remember? That is one criteria that we're testing. So the rig gives you this. This is the furnace, combustion chamber. This is the treatment. This is fuel. So the fire is breaking out here. So as part of detailing of the system, you put it to test, you must include this element. This is a very, very crucial element because you are testing for the resistance or the performance of the cladding against the fire breaking out from a combustion chamber. So if you only focus on the design of integrity of this with the fire coming in this direction, and you don't put the effort on that detailing, you may actually fail because that is the most crucial detailing. When the fire breaks out, if you don't detail that correctly, the fire will burn right through. Unless you say that your system is so chunky, fire burning through the cavity is still hard. Okay, let's see how to do it. But what I'm saying that these are the performance criteria. Again, the standards are not prescribed to you how to do it. It's on you put it together. And so that will be a driving system for both systems. For part 2, there's an additional definition of internal surface. And now decided to fire, decided to burn. This is the expected performance. These are the parameters and the areas of which there will be measurement, there will be visual observation on the performance of the cladding system. There will be the plane from the outside, temperature of the external thermocouple. There will be a plane from the inside and the internal thermocouples. Right? There will be mapping the spread of plane upwards. They will be measuring the temperature at 1.2 or I think 1.5 is important. At the lowest here, the layer of the thermocouple will be the thing. They'll be observing how visibly, how where are the visible flames, are they swaying outside the big or not? And then they're observing falling the leaves and all that. But this is actually the criteria. And additional criteria for part 2 would be performance of the internal surface to prevent internal system burn through. So that would be an additional criteria. For part 1, the whole system can burn through, provided of course the plane of flame within the performance criteria will pass. Right? Because you're supposed to have a visibility wall and prevent the light from getting. But with part 2, it is your responsibility for the burn through. So your system must be tested. So in the scenario, for example, you say, well, my system is only one supposed to I'm sending for part 2. Yeah, you prove to them how to prevent the fire from actually going through. So that's the criteria. That is what the ESA 414 all about. I'll show you this video. I refer the various insulated material inside cladding system. That extruded polyurethane, rock wool, PIR, and rock wool. These two differences are on different surface. I think this one is the laminated, something. This one plastic surface lamination. So the only difference that this one refers to the insulated material find the actual cladding insulation. So let's look at this test. This is not exactly a very big test because they didn't start at the same time. So it's not exactly to be a satisfied immediate comparison. It is more of a visual test for us to visually acknowledge and visually understand. The file is all set. We're just setting the file one at a time. Okay, let's start a story short. after about 2 minutes. Of course, after the fire a bit earlier, so the fire quick matured a lot faster. When you start seeing the performance, here you can see that this aluminium material started to char on the surface. And this similar material also starting to char on the surface. And this one, they started to burn a bit later, so we haven't actually stopped yet, so not charring just yet. But just fast forward a bit more. And at about 5 minutes. Remember, this fire was started a bit later, just a few seconds later than the first one. So this one, the surface is charring already, but it's not actually contributing phase. You can see the lamination is breaking up. The virus is actually so you can see the lamination, and the lamination is now exposing the insulation. And once it breaks open like that, you can see that the body is actually within the cavity already. So it's burning through the rock hole and trying to burn through the rock hole. This one here is operating exactly the same fate as the PIR. So this is what happens. Once the surface breaks through, the fire hits the PIR, that's it. PIR is controlled fire. It just burns and burns and burns. And this one was failed already. It's just on the visible plate. He has already failed. Right, then another one on rock hole. This one, the fire was started a lot later, but it is still charring the surface, so handling very well. Yeah, obviously the rock hole is just not burning. The rock hole is doing what it's supposed to do. It just doesn't burn. So that's very good. So PRR is the corner. Then you say, well, then not too bad lah. Use the cheaper polyurethane. But remember, this fire was started last. They started the fire here, and then this one was at least about 2 or 3 degrees last. So PRR is the corner. Okay, they have to put out the fire already because it's cannot be controlled anymore. But then you look at what's happening with polyurethane. The rock wool is still burning. Look at what happened to polyurethane. So the moment it captures is again in a controlled fire. So the polyurethane or one shot the black smoke that's highly toxic. So that's why PRR is still a little bit more acceptable, but PU, no way. So we do know, we have a lot of, the use of phones and all that. Yeah, it's far home because the attacking on the surface. So we accept that, but our caution shall be, you have to recognize PU, PIR, all these poly materials and highly combustible and highly combustible. So that one brings us then to our detailing. If we actually specifying this under the ethics class O B, be very careful how we detail the form, how we detail the areas where we are opening, where we are opening through. Yeah, that we want to ensure that the fire remain on the surface and they will not burn through it into the insulation. But that is the more critical performance. And you look at that now, how they just put on the two robots are still burning, they have no burn. Because it's not burning, it's actually not burning. But they don't even try to put out free fire, just let it burn. Okay, so the next one. So a very quick case study now. This is a project that we did 2 or 3 years ago. The Chong Lee Siong earlier, that is about So, a bit of history in terms of the timing of this project, we got our building plans approved in 2019, late 2019. I believe you got your first DSA 414 round about June or July 2019, I think. August 2019. We got our building plan through in around November, I think, around about the end of 2019. So we were ready to construct, but of course we have not submitted any specification of the development because I was still in the Bombard committee talking about this, how to be implemented. The directive was only presented in August 2021, almost 1.5 years later. But we were already doing on this project, and of course, it will be totally irresponsible for me not to immediately introduce 8414 requirements to this now. Right, so it wasn't legislated yet by the time I already started studying the detailing and all that. The actual contract has not been awarded yet at the time. This one went to SC. We have nominated some contract handling consent to get the fabrication of the curtain wall system. So it was way before that, but our specification we already out in the requirement of the for. So we came up with the detailing, we came up with practically everything that we need, how to do it. Then came 202. Of course, it was too big. After it was 2019, we were ready to get on to the Powercast, then March 2020. After we immediately became the first thing we did was revolved the block. So it didn't stop for too long. We got the meeting approvals by May 2020. We were actually already back. So the nominated contract is Spain, and we managed to clear that through by the third quarter of 2020. And by that time, we already got all our the bylaws written already for implementation of the FA 414, but we couldn't effect it. So Bombard is mulling already at the time. Okay, I have to find a very another issue of directive to get it through, but cannot wait on the bylaws. And of course, by ourselves, we didn't open up the facility. And I think you're one of the first. You were the first one of them. They were actually, so there was a bad opening where they used Italy's sample, and everyone said, oh, good, that's fire. So, it was pretty good. First time for everybody, all the learning. So, I had to already make sure that I'm in compliance because I know the moment they endorse it, the Bombard not going to give any chance. Bombard said there will be no grace period. Once they issue the directive, all buildings that are not built, even though you've got approval already, but it's not built, you have to comply. So, of course, we have to do our homework way before that, knowing that that's easy. So, cut a long story short, we did our detailing with our full understanding of how the DSA 414 had created, and at that time we didn't place comply with the it was our own detailing. We were using our own criteria, using our own understanding of what is expected of the performance testing. So we did create all of this, and when the time came when we awarded the contract with SC, all the documented, we gave the documents to the contractor for the tendering. But of course, I'm sure that's what we do. Yeah, I can give you all my detailing and the contractor includes. So we put out there no matter what the contractor must do. So I think at the time the contractor, the winning contractor really represented to us who would be the then when we called up the contractor, we started making the tax sheet and all that. We said, okay, now we have to try to identify which section of the wall or how we visit the tax sheet, as you can see, is standard. only 2.4 meters, one wing wall of 1.2 meters, and what is it? 16 meters. So it is the technical standard. So they call it a full shield test, but no lah, full shield test, this is five lah, make a full shield test. We still have to identify a section. If we don't identify a section that covers all our detailing, it will be a problem. You have to say every section in different tests, then you get about 5 or 6 certificates. Applying to the children, you have to meet standards of the job, no allowance for additional test. So, actually what we did was, the supplier then, for some reason, mid 5 seasons and all that, they introduced another cladding. This one they introduced Italy. They said that Italy already got before 1 certification. I said you don't have to test our system, spend so much time designing it. I said, look, you want it far, we actually got one. So we did a bit of reverse engineering. We looked at what was tested, what was the tailing that was already used in testing. We interpolated it and we made adjustments. We made adjustments to where we put the fire barriers. And this one here, this building here has got various different sections because the internal functional requirements of the building is very different from all the components. You've got the officer, which is primarily just a glass curtain walling. You've got the cable manufacturing, which is 2 or 3 layers of walls inside. The masonry, then you've got certain areas of the concrete board, we have the windows, glass. So there are quite a few different situations in the kind of building. There are quite a few different situations. So if we are to go for a specific PS414 test, it's going to be a lot of time. It's going to be a lot of different testing sessions. So even at the time only got 1 week. Also, if we can book the date for the next 5 months and we still wouldn't finish. So I did a bit of reverse engineering. We took what was tested and we looked at the criteria, we looked at the dimensions and the specification of the material, and we did our own interpretation. So on that basis, we came out with certain detailing that allowed us to do what we wanted to do, but at the same time ensure that we complied with the political code. And that included things like, I don't know if you can see here. Okay, it included things like this. So these are the concrete things that we have to extend out. Because if I remember correctly, the detailing there was very standard of 110 or something like that. So they have one barrier. They use several rights or feature on they use feature at the other spot. So the one about the specific inlet length. So we cannot change that. Say I cannot ask now to say, oh, because of our bigger cavity, can you use a bigger fire spot? So because those elements tested and informed that way, so what we did was to use uncompatible clause lock, the extended complete things. Wherever we have the cavity, you can see the building here. Okay, you see that part over there. That's the window breaking out. Right? So wherever we have a cavity, this cavity is so it's way more than the cavity that got approval. But what we did was we extended slab. We have this non-conformable structural thing coming out. So that at the point of where the fire stop, the component of the fire stop is exactly the same level. Yeah, and we ensure that there's nothing in the cavity. These are not insulated adding, so there's only an air gap. There's definitely no material in there going. Right, so that is how we inspected the original intent of the wall. So in a way, we shortcut it. Then we say, now how can Boba allow that? Say Boba also not too well learned today. So what is Boba doing? Boba, I think you're the architect, right? You're the one coming from, right? So that's what we analyze it and we develop it. Believe truly that this one in the spirit of the test result of larger. So from there, so we learned a lot. It was really good even during the construction. Oh, but this is also documented in the so it was very interesting that we have all these standards and those then we should and every single pattern documented. So we got a particular code. So if one of the panels is dented or we need a replacement or something, we just refer back to the bin and hopefully the supplier can still remember how to even for it. And it is our because we never dealt directly with the children. This part here on the wall, this is where we have a starter bar feature extension. So it's just cladding around the starter bar. So again, this is definitely not test sample. Okay, so what we did was we had final stops at the right intervals one catching. So yeah, so that so forth. Yeah, we're quite happy that when we finished all the expert and Boba just said, okay, actually the question really numerous. They go to every detail, they look at every one. Ini tak sama dengan itu, kita ada. Oh, they really do the but then I'm saying, okay. Okay, after we finished it, I'm all happy and we delivered it. So in combination with the fire stop and with this PSA 414, step 7 is after you done a good job with the paper. And then we bring everyone to the site. We order for that so again, I want to sign the kind of and okay allow me to listen to everyone. For that, I think thank you very much for the attention.
This is the last one. Oh, which one is this? Sorry, Lava. I don't know which one is the last one.
Right.
Okay. All right. Okay, I think we had a pretty good session. I definitely learned a lot. I think it's quite this I think recording on it is definitely not something very common that we do. I think that's where the standard is at. So we run out of time, but I think I will then probably enough to learn all this. Open up the floor for questions. Any questions of the floor? See if there's a question or not.
None.
So,
how to define the difference between cladding and sunshade and cladding.
It's supposed to, as I mentioned, it's supposed to replicate a fire burning out of the reaction of whatever it is that you have involved. So I would say anything you put on the surface of the wall, cladding and all that. Now, our case, yeah, I think we are all really as well as something of first we have a situation where we out of. So yeah, I would say in general it does cover. It does include inverse, cladding, holdings, anything that comes experience. However, one at the end, remember the non-master repeating. So if the materials are generally unavailable, if it is not forming continuous cavity, You have no installation, you may just but we have not tried yet, not even yet. I hope the lead of us given any specific report on all this. So I would say again, exactly what we're planning to go in full definition of what a full solution.
Another question, following that. Shake only without effect.
Something that just is not like that.
Whatever, I mean, instead of cladding, actually, it's going to be tested.
I would say by definition, yes, but again, we'll be very happy for those things that have taken them. Let's see what's it called. We'll be very happy to follow it. But I think when it comes to the ball, I think that's the case. So, what I'm saying, much, it's not a case of whether it's setting one up. If I need to do this, I think it's very much about preparing ourselves to have our own story so well documented. So, we can go from our home, but let me show you this beautiful building. And this is what I've got for, this is what I've done, this part. All the standards. I think that involved. You'll be very happy to go you face and sure.
How about solar panel installation?
Yeah, solar panel is a totally new element. Don't know actually, you want to talk about. In Bonga, we are currently identifying a classification of spectrum regions. But I tell you, the EV charging station is really now. And now very simply, just March, the new directive set out that anything to do with the handling of lithium-ion batteries, definitely EV charging station taking a lot of parts of it. The battery of you. So anything to do with the handling, testing, manufacturing, storage, lithium-ion batteries, that classification from back to because anything to do with data centers, bring it back to it's not how it's done. It's just that one part of that thing is centralizing all. So they want to see you consultants, what is your design solution for this? So that's what. Eventually, I think there should be about 6 or 8 different classifications under this spectrum. So yeah, the fact if you have this situation when running the only the one is first. If you want so I think let's take on
Okay, we have one question online with regards to fire stop. So we ask, for pneumatic waste weighing system something of 600 tons, which is not fire related, when we do we need a fire damper or fire stop? The example given in the MS format, we need something.
Okay, the easiest way to address that is to put that into a protected lobby. That would be easier because I cannot say you have to put fire damper or you don't put fire damper. Because if I say you have to put fire damper to be technically correct, then they say, where got fire dampers for refuse shop? Then if I say you don't have to put fire damper, then you stop me immediately. You go to Mumbai and say, this right here, you think of the fire damper. So I'm saying that the practitioner of the shop So the easiest way to address this is really by the multi-situation. Yeah, so the entire shop, the thing of the lobby, when you entering the lobby to show you two things, you violate the order. You know, and then it's all like that.
Okay, any other question? Usually very shy Malaysian. Okay, I think we crossed the time, yeah, and so you get any other question that you wanna ask. You know, privately with that and still here. So with that, close we can come over to send to begin to our speaker and also that we and we so if for you for sponsoring, I think the both your topic and what our like Steven is very relevant. Okay, so with that we end this talk. Don't forget to sign up and leave. And see you in the next video talk. Thank you.